Hi friends, I am Miss Kat. I'm one of the STEM educators at Boys and Girls Club, and today I want to propose a challenge for you to do at home that's all about engineering. So lately I've been going outside and it's pretty hot, and that makes me always think of water parks, but unfortunately since they're closed right now, I was thinking, how can we make a miniature water park at home? Even though I don't want us to put water on what we're about to build, it's still going to be a replica of what we might see at a water park. So all you're going to need for this experiment or challenge is one paper plate. I have about 8 paper cups right here. You can use as many paper cups as you want or as you have at home. I have a bunch of tape, and then I have scissors, and that's all you're going to need. So there are 2 types of water slides that come to my mind when I think water slides. So the first one is the one that goes straight down. It's pretty simple, pretty self-explanatory. It's the one that gives you the biggest rush where your stomach feels like it's about to come out of your mouth. And then the other one is the ones that go like a spiral. And right now, I'm going to try to do the spiral run. But I would want for y'all to pause or stop this video and try it on your own and see what you can create to have something start at the top and then work its way down to the bottom. And so I don't have a ball or a marble or a bouncy ball to test this with, but we're gonna see what I come up with anyways. So like I said before, I wanted to make a spiral water slide. So what I'm going to do first is just cut my plate into a spiral by keeping about an inch away from the edge as I'm cutting. And then I wanted to make little walls, that you would find on water slides so that when you are going down, the ball will not fall out. And I'm making these walls by bending the plate inwards. Now I'm going to add some support to my slide, and I'm just going to be stacking cups onto each other so that it's tall enough to support it. This support will make sure that, the slide actually stands up. And from here on out, I'm just going to keep bending my slide so that it forms around the cups, and I'm going to be adding more cups so there's better support for our slide. So I'm going to be talking about a little more about the physics and the engineering behind these slides as you watch me do this. So how do we get from the top, which is our point A, down to our point B, which is the very bottom? So when you are at the top, you are at rest. But when you first step onto the slide, you gain full velocity or you increase your speed because you are accelerating because gravity is pulling you down. And there's also a reason why you go down a water slide faster than you would a normal dry slide, because when you are going down, say, a slide at the playground, there's friction between your body and the slide, which causes you to slow down. In a water slide, the water acts as a lubricant that builds a barrier between you and the slide so that friction is decreased. Something else that's different, though, between a serpentine or the spiral-like slide versus a straight-down slide is that there are higher walls or, barriers between you and literally, like, the air. Because when you are going down on those curves, you are going down at such a fast speed that if you didn't have those high walls to bounce back on, then you would just theoretically fly off. As I'm working on this, though, something that I'm constantly asking myself is my slide supported? If I put the weight of the ball on here, will it fall over, or will it, as it's going down, fall off? And so those are all questions we need to be thinking about when we're engineering these slides. All right, I think I finally finished mine. It doesn't look the greatest, obviously, because we didn't have a whole lot of materials to work with. I still have 2 cups left because I didn't really see a use for any of mine, but this is the side view of it, and I'm about to show you the top view. You get the top of mine, the ball will start right here, and it'll work its way all the way through here. And I kind of I added more like wall to the slide because I was afraid that if it just stayed on the plate part, it would fly off because it has so much momentum and such a great increase in velocity as it's going down. I didn't want it to fly off, so I added a wall using just tape. And then it goes through like this little tunnel thing. Woo! Then I added more wall, and then it goes all the way to the bottom. And it looks like a snake tail, kind of. So that is mine. I would love to see what you can come up with. So I hope you try this challenge at home. Well, thank you for watching, and I hope you stay tuned for more STEM videos.